Well, hello pre-calculus students and seekers of general truths. In this video, I will show you how to solve an equation that involves combinations, all right? And this is not an equation that's typical because there's factorials and it's very complex. But we always go back to the definition of what combinations really is. N choose 3 is really n factorial over n minus 3 factorial multiplied by 3 factorial. Okay. And then n choose n minus 1, well, this will always turn out to be equal to n. Okay, so this is something that we could discuss about in greater detail, but I will show you here that really n choose n minus 1 is always going to be equal to n, because this is also the same thing as n choose 1. Right? This will also be equal to n. So it's kind of like saying if you have n objects and you had to pick one of them, well, there's only n ways to do that. Right? If I had 20 people and I had to pick one of them, well, then there's only 20 ways for me to do that. Now that's the same thing as saying n choose n minus 1, because to choose one person or to choose one object is to eliminate n minus 1 objects. So it's kind of like saying if I have 20 people and I needed to choose 19 of them in a group of 19, then I might as well just choose one person to eliminate, right? That's the exact same process. So there's a symmetry here with combinations, and you can see the symmetry in Pascal's triangle. But for the sake of this problem and your understanding, I'll expand this so you can see n factorial over n minus 1 factorial multiplied by n minus 1 quantity factorial is equal to 4. Okay. So when we solve these factorial equations, we're going to expand everything. I'm going to do a little bit of cleanup work here in this first term. So 3 factorial is just 6. And again, when we are solving these equations, what we want to do is eliminate or clean up or simplify the factorial as much as we can. I'm going to put this in a square bracket so it stands out a little bit, because it's really hard to solve an equation with a factorial. And here you see n factorial, n minus 1 quantity factorial, n minus 1 quantity factorial, and n minus n, and then minus negative 1, well, that's just 1 factorial, but that's the same thing as 1. Okay. And here, this is not a proof. We are solving a problem here. All right. So let me scroll down a little bit. So from here, well, you can see that n factorial and n factorial here is really the same thing as n times n minus 1 factorial. Okay, so this is one of the basic properties. So that's gone and that's gone. Now, this n right here, we can expand it into a couple of different levels here. So this n factorial rather, so let me show you that. So this is really n times n minus 1 times n minus 2 times n minus 3, all of that factorial. And that also tells us that we can eliminate this and that. Okay. So having a command or an understanding of factorials is hugely helpful to us. So now we have a 6 in this denominator, and what we can do to simplify things, well, we can get this, well, let me just write this out in a couple different steps here. So we have n times n minus 1 times n minus 2, right? All of this over 6. And over here, I'm going to multiply the top and bottom here by 6. So this is going to be 6n. All of this over 6 is equal to 4. Okay. Let's continue our work on over this part here. We multiply both sides by 6, and we end up with n times n minus 1 times n minus 2 plus 6n is equal to 24. Okay. And so what we effectively end up with here is kind of a cubic function. So the cubic function that we end up with is if we multiply all of this out, we're going to get n to the third, right? Because you're going to have n times n, right? So that's going to be n squared, and times this n is going to be n to the third, minus 3n squared plus 2n plus this 6n equals 24. Let's simplify, move things together and simplify. N cubed minus 3n squared plus 8n minus 24 is equal to 0. And then we're going to go ahead and we're going to continue here, and we're going to factor this cubic here. We'll factor it by regrouping. So we're going to take this first group and this second group. This second group here, we're going to factor out an 8. So 8 times n minus 3. And this first group here, we're going to take out an n squared. N squared times n minus 3. All of this is equal to 0. Okay. So now we factor one more time. N minus 3 comes out of both groups, and we end up with n squared plus 8 is equal to 0. Right. The second factor here, I'm going to leave it to you, but basically it doesn't give us anything real. It gives us an imaginary number. But the first term here, we can factor that out, and that turns out to be 3. So our final answer to this problem is that n is equal to 3.